All right. Okay, so let's start with number 1A, Brandon. Just give me your answer for whatever it is. Kalau ada orang yang tidak setuju, tolong suarakan. Okay, so that, yeah. Brandon, 1A, your answer is?
13 Newton.
Okay, 13 newtons. Why 13? Why 30? Shouldn't be 13. Shouldn't be 30. The resultant force on 1A.
Sorry, 23.
Okay, 23 Newton. All right. Next one, Damir, B. Sorry, saya ikut abjad ini so yeah.
50 Newton.
50 newtons is almost correct but not fully correct. Boleh betulkan?
Negative 50 Newton.
Negative 50 newton. Okay. Kalau kamu tulis 50 newtons, you have to write 50 newtons to the left. Okay. Ayat ini sama ini, okay, adalah benda yang sama. Okay, cuma ini adalah 50 newtons to the left, ini negative 15. It means the same thing but written in different ways. Okay, 2A, Adam, what is the value of F?
7 Newton.
Okay, 7 Newton. Kalau orang, so guys, check your answer with one another. If you are not agree with the answer or if you don't know how to find the answer, please unmute yourself and ask me, okay? Because otherwise saya akan teruskan sahaja. Okay, next person, Elijah, 2B.
Negative 2 Newton.
Negative 2 newtons, okay. All right, very good. 3A, Eva, resultant force will be? I don't know. Okay, never mind, Udina. 3A, Udina.
7 Newton to the right. Oh.
Sorry, I only heard right.
7 Newton to the right.
Okay, very good. Isabella, 2B, 3B.
Negative 2N.
Okay, negative 2 newtons or 2 newtons to the left, depending on how you want to write it. Jacinta, 4A.
Negative 4 Newton.
Negative 4 newton. It's not correct. Yeah. Oh, the resultant force is 12. Okay, and we assume that 12 means positive lah. Okay, so where should, if the resultant force is 12, means it's 12 equals to F minus 8. Okay, to this one. So you should get F equals to 20 newtons. Okay, read the question properly, be very careful. Okay, all right, 4B, Jericho. Okay, never mind, Christopher.
Apa ni? Negative 7N. 7 Newton.
Okay. So there are two ways of looking at this. Jawapan si Christopher is negative 7 newtons lah. Okay, but actually if you think about it, kalau sini negative 7, 5 minus 7 is only negative 2 bah. Okay, so this is a slightly this one lah. We have to assume that the 12 newtons is to the left. Okay, because there's no way that it can be to the right lah. Susah kita mau to the right. Sebab ke kanan kan hanya 5 newton sahaja. So we have to assume that the resultant force is negative 12 newtons equals to 5 plus F. Okay, so you actually get F equals to negative 70. Oh, you're so ugly, my handwriting. Negative 17 newtons. Okay. F equals to negative 17 newtons. Because that's the only logical explanation. Kalau ke kiri adalah negatif 17. Okay. Dan ke kanan adalah 5. So your resultant force will be 12 newtons to the left. Okay, so part of the problem with this question is in the question itself lah. It doesn't tell you that it is 12 newtons to the left. Okay, so you have to. This is not really your fault lah. Okay, it's more on the question, so don't worry about it. But we still hold on to the same principle. Okay, follow the resultant force. All right. This one is no question. The next one is page 4. Okay, page 4. Okay, page 4, Lester. 1A first, resultant force. Lester, are you there? Oh, okay, negative 1 Newton. Negative 1 Newton. Nasib baik saya nampak the chat, otherwise, okay. Next person is Michelle.
Five Newton.
Okay, 5 newtons. Okay, and now we come to the resultant force that involves a 90-degree angle. Mordecai, 2A, please.
17 Newton.
Okay, 17 newtons. This one, actually, even if you didn't draw, you can actually this one lah. Okay, as always, we finish the parallelogram, and then you draw the over here. Oh no, sorry, I missed this one. Okay, draw the diagonal, and then since this is a 19-degree, okay, so this is 8, 15, and then you use Pythagoras theorem, you can get 17 lah. Okay, Shim, next one, 2B.
13 Newton.
Okay, 13. Okay, Newton pun boleh. Okay, sorry, I made a mistake. Mordecai, can we go back to 2A? What is the direction of this? Did you write the direction? Because the resultant force is here, right? So what is the direction of this? How do we count this direction?
More angle kah, sir?
Yeah, more angle.
Wait.
What do we use? What do we use? Tell me, what do we use?
Sine.
Okay, sine theta equals to?
61.9.
Oh, sudah dia kira. Theta is 61.9. Are you sure? Hold on. Sine.
From horizontal, kan?
Yeah. Are you sure you're using sine?
Hey, wait. No, it's cosine. Wait.
If you use cos,
28 angle from horizontal.
28.
Yes.
28.1.
0.07.
Okay, 0.07 degrees to the horizontal force. Actually, even if you use sine or cos also, doesn't matter. Like yang penting, if you're using sine, it will be sine 8 over 17. Okay, if you're using cos, it will be cos 15 over 17. You will still get the same answer, 28.07. Okay. All right, Shim, how about this one? What is this angle?
67.38.
67.38.
Yeah.
Okay.
Degree.
67.38 degrees. Okay, all right, good. Sorry, shift cos. Hold on, I'm checking something. Oh, okay. All right, so don't forget, if you're counting the resultant force, make sure you count the angle. Okay, except for in this case lah. Okay, in this case is a little bit it's a little bit unique. You don't have to count the angle unless you're using a protractor. If you have a protractor, even better lah. Okay, Rania, can you tell me the answer for number 3, please? What is the resultant force? The value of the resultant force here?
400 Newton.
400 newtons. Okay. Can you explain to me how you got this 400 newtons?
First I choose a scale of 1
Okay.
cm to 50 Newton.
Okay, very good. And then, oh, okay, and then you draw lah, kan? Okay,
Yeah, I
obviously.
drew a new one. 5
Okay.
cm, like the line 5 cm.
Okay.
And then
5
I
cm.
drew with 50
Okay.
angle and then 4 cm to the side.
Okay, very good. So how long is this? After you finish the parallelogram, how long was this in cm?
8 cm.
8 cm, huh? Okay, so that's how you got 400 newtons. Okay,
Yeah.
good. Very good, very good. Okay, that's exactly what needs to be done now. Okay, let's continue. Good job, Aranya. Tian.
Yes.
Free body
Normal
diagram.
reaction.
Okay, where is the
Sang.
direction?
Up.
Oh, sang. Huh?
And
Okay. And,
down. Right.
okay.
And to the left, right. Right.
To the right. Okay.
Maybe that only. 还是还有 or is it to the left too?
Yeah, there must be always a force to the
Oh,
left. If there's a
okay.
force to the right, so ini yang menarik bahkan. So I'm going to call this the F lah, the pulling force. What is this left one called?
Friction.
Very good. Okay, frictional force. Now remember, frictional force. Oh my word! Sorry, my writing. What is happening to my pen? Okay, so frictional force. How you know there is frictional force because of this sentence. The surface of the ground is rough. Sorry, my handwriting. Okay, surface of the ground is rough. Means got friction. If the surface of the ground is smooth, like glass, okay, then there's no friction. So this is a very important thing that we must remember. Whenever you see the words rough or smooth, okay, if you see the word rough, means there is friction. If it is smooth surface, then there's no friction. But in this chapter, we're very interested in rough surface because that's reality. You know, when you pull something on the ground, then the surface is always rough. There's always going to be friction. Okay? All right. Continue, Tian. B. Compare the normal reaction and the weight of the box.
Same.
Okay, same. Very good. C. Compare the tension in the string and the frictional force.
Same.
How you know it's the same?
Because it's constant.
Very good. Because it's constant speed. Anything that moves with constant speed means, is this box going to move? It is going to move. Okay, but the force and the frictional force is the same. Okay, very good. All right, number 2. Valerisa.
Atas normal reaction,
Okay,
di bawah weight,
all right.
di dekat string tuh pulling force,
Okay,
yang sebelah dia frictional force.
okay, very good. Compare, please.
Normal reaction equal to weight.
Okay, same.
Yes.
Tension and the frictional force.
The string bigger than frictional force.
Okay.
The tension in string
the
is
tension
bigger than the frictional force.
Okay, it's bigger than the frictional force. Very good. How do you know?
Because they are accelerate to the right.
Very good. Okay, asal acceleration means the forces are not the same. Okay, so there's a difference in the question number 1 and number 2. Okay, and I hope that by doing this exercise, you can see that the thing that determines whether the resultant force is 0 is whether there is acceleration or no acceleration. No acceleration, resultant force is 0. Okay, good job. Well said. Number 3. Final answer. Just give me the final answer. What's the mass of the car?
Kilogram.
Sorry, how many kilograms?
500 kilogram.
500 kilograms. Okay, can you tell me how you got this answer?
F equals,
Okay,
and then given that 1000 Newton equals to mass and 2 acceleration, and then pindah-pindah.
Sorry, I didn't hear the front part. What did you say in the front?
1000 Newton.
1000.
Yeah,
Okay, equals to
M
times. Okay. All right, m times 2. Okay. How do you get this 1000 newtons?
1500 Newton minus by 500 Newton.
Okay, minus by 500 newtons. Okay, very good. Okay, so actually, although this 1500 newtons is to the left, but since it is following the direction of the acceleration, it is accelerating to the left now. Okay, so we don't have to really think about the left, right now. Okay, next person, Wilson, number 4.
1.33 ms negative 2.
1.33 ms negative 2. Can you tell me how you got this answer?
2000 Newton equal to MA.
Equals to MA. M is 150.
Yes.
Okay. This is not correct. Unfortunately, it's not correct. Okay. Think about it. Let's draw the free body diagram. Okay. This is a rocket. It's a very ugly looking rocket. Doesn't matter. So it's going to go up with 2000 Newton. Wilson, can you tell me if there's a force going up, there must be a force going down, right? What is the force going down?
Gravity.
The gravity lah. So how do we count the force of gravity? How do we count the force of gravity? Actually, same case. 9.81 times.
Times 2000 Newton. Is it?
Cannot. Newton is already force. Must times with something. Okay. So this is where we can learn something lah. The force of gravity is also known as the weight of the rocket. Okay, so the weight of the rocket is 9.81 times with 50. Okay, so it's okay. Don't worry, we make the mistake here. This is where you learn. Remember, every force must have a counter force one. It may not be the same, okay, but there's always two forces at work. Okay, up, down, left, right. So your 2000 here actually is not correct lah. It should be 2000 minus with this one, 9.81 times 150, which is 1471.5 equals to 150 A. Okay. So don't worry, okay, don't worry about getting this wrong, but I want everybody to learn from this, okay, that it looks like a very simple question, right? But actually this question tests whether you remember that if there's a force upward, there must be something that is pulling it downward, because that is the law of our universe, of our world. Okay, if there's a force upward, there must be a force downward. Okay, sometimes it's equal, sometimes it's not equal. Okay, so then we must always think in this lah. Okay, there's always more than one force. Okay, which is the exact same situation as the elevator. Okay, which we are going to come to now. All right. Okay, question number 1. Zulaika.
686.7 Newton.
686.7 newtons. B.
896.7 Newton.
Sorry, what?
I'm lagging. 896.7.
Sorry, I totally did not catch what you said. I'm so sorry. Can you repeat that again? Oh, okay. I'm lagging. Okay. Maybe you type it up for us. 896.7. Okay. How about C? 546.7. Okay. Okay, because there's a lot of calculation involved here, I just want to ask whether the rest of you agree with this answer, or is there a difference? Is everybody okay with these answers? Is this correct?
I got the same answer.
Can.
Sorry, who is I got the same answer.
Me. Dina.
Oh, okay,
You,
Dina.
Okay.
Okay, all right. So at first glance, when I look at these answers, it looks very legit lah, because it makes sense. Okay, at rest means the reading on the scale is R, okay, will be the same as the weight. So good lah. Okay, you just 770 times 9.81, so you get this. Accelerating upwards means the reading will increase, okay, which makes sense because when the lift is going upwards, you're going to feel heavier. When they're accelerating downwards, you're going to feel lighter. Okay, so this seems very legit to me lah. Okay, good job, Zulaika. All right, next, let's go back to Adam. Number 2, please.
Two A.
Yeah.
740.5 Newton.
Okay. 2B.
1056 Newton.
Okay. Does everybody agree with this answer? Okay. Wilson is lying down on his bed and doing this already lah. So why don't you tell us what your answer is, Wilson?
Oh, 565.5 Newton.
Which one?
B.
B is 565.5 newtons. Okay. So Wilson, do you agree? Is this the same?
No way.
Okay. What do you get, Wilson?
For A, I got 490.5 Newton.
Okay.
And then for B is 415.5 Newton.
115.5. This is a very big difference between Adam's answer and Wilson's answer. So who are we going to trust? Do we trust Adam or do we trust Wilson? Do you think that Wilson is trustworthy or Adam is trustworthy? Or does the class think that these two are not trustworthy at all? That we totally cannot depend on their answers? No, Elijah trusts Wilson. So do we trust Elijah? Let's play a trust game. Kita tengok siapa yang boleh. Okay. Let me ask Wilson. I trust her. Wow, okay, fine. Thank you for trusting me. Okay, I'm very honored by your trust. Okay, let's consider Adam's answer first. Adam, how did you get 740.5? Can you explain to us?
Since the elevator is moving upwards, that means the R is bigger than W. R is bigger than weight. So that means R minus W equals F. So to find the reading on the scale, R equals to F plus W, which is MA plus MG.
Okay.
So then the mass is 50 kg. The acceleration is
don't curse, guys. This is going to be on YouTube. Okay, don't curse. Don't curse. Okay. Now do you see where you went wrong, Adam?
Yeah.
Okay, you saw. I wanted to bring you to that point. The acceleration is how much? Can anybody tell me how much is the acceleration for the case in 2A?
0.
The acceleration is 0 because
it's constant speed.
Because it's constant speed. Okay, so this is where the danger of calculation questions comes in. Most people, they see the number 5, they immediately, like Adam, I'm sure, you immediately thought that it's 50 times 5, right? Because you didn't see the word speed. Okay, be very, very careful with this. So for those of you who supported Wilson, I congratulate you lah. Okay, you are supporting the right team for this question only. Okay, you are supporting the right team now. Okay, Wilson's answer is correct. Okay, in both accounts lah. I think that for Adam, dia punya B is dependent on A lah. So his B is actually correct, but the problem is he did not read the A question properly. Okay, so Adam, this is where we can learn something lah. Please read the question properly and really understand. Okay, if the speed is constant, there is no acceleration. So the question 1A and 2A are the same thing over here. If that is the case, so the other question that I want to ask all of you lah as a class is, kalau begitulah dia punya case kan, buat apalah dia mau bagi ini 5? What is this 5 here for? The 5 is there to confuse you, okay, to catch people like Adam, okay, who after when I ask, then sikit lagi dia mau dia mau memaki di YouTube. Okay, so be very careful with this. Okay, so good job to Wilson and all of Wilson's supporters for today. Okay, good job. All right, let's go to the pulley question. After Adam is who? After Adam is Brandon. Because I don't see Eliska and Angeline. Okay, Brandon, 1A, please.
$98.1.
98.1. Okay. 98.1 unit.
Newton.
Okay, Newton. 1B.
113.1 Newton.
113.1 Newton. Does everybody agree with this? Okay, I think it looks legit to me lah. Okay, can 2B, Damir? If you don't agree, please let me know. Or if you don't know how to find this, also let me know. Otherwise, we'll just continue. Damir, number 2.
2A 49.05 Newton.
49.05 newtons. Okay, 2B.
34.05 Newton.
34.05. Accelerating downwards. Okay, I think it makes sense. Is it okay, everybody? Is this okay? Okay. All right, if this is okay, everybody. Sorry, I want to apologize for our previous class because kan saya ajar benda ni kan dan saya tersilap ajar lah. So I hope that the correction video that I made was helpful for you all. Okay, please remember that in this kind of question, okay, usually there's the simultaneous equation involved. Okay, the simultaneous equation where you have to find the value of A and then after that find the value of T. Sorry, I don't know what is wrong with my pen. Find the value of A and find the value of T. Okay, usually that's the case. All right, number 3, Elijah.
3A 4.3 Newton.
4.3 newtons. Okay, 3B.
9.5 Newton.
9.5 newtons. Okay, 3C.
1.143 kg.
1.143 kg. Okay, hold on now. Yeah, I'm does everybody agree with this answer?
For A, I got 4.5.
4.5. Okay, yeah, which is the correct answer. I'm kind of wondering how Elijah. Oh, okay. I think it's possible. You know why? Because Elijah doesn't have a hard copy. You don't have this question, right? You have a digital copy of this kan? Because Elijah belum ambil buku teks bahkan.
Belum.
Yeah, belum. Okay, so anyway, okay, this one is 4.5. How about B? Is this answer correct? B is correct. Okay, C? C also correct. Yeah. So the A was the one that was like, huh? How do you get 4.3? Yeah. 3 times 1.5. Okay, is 4.3. That's how we would get this.
Salah kira, sir.
Salah kira. Okay. Udina, number 4, please. What is the tension and what's the acceleration?
My tension is 65.4 Newton for
Okay.
both sides.
All right.
And then I got an acceleration of 3.27 ms per square.
Okay. Per second squared.
Mm.
Okay. What are the rest of everything? Ken? Is this answer okay? All right. So this number 4 is probably the one that you have to do simultaneous equations lah. As I said before, just kau dapat dua-dua jawapan at the same time. Okay. Now, that's it. Okay, that's it for today. I think if you're all able to answer all these calculation questions, it's good for you. Okay, but I just want to remind you that this is only the first part of this chapter lah. Okay, next week we are going into this subtopic, which is called resolution of forces. It is a little bit more difficult, but I want you to remember everything that we have learned in this subtopic. Okay, the 1.1. The most important thing that we need to remember is the resultant force must follow the direction of the acceleration. Number 2, in almost every situation, there are always at least two forces, working to produce a resultant force. Okay, so remember Wilson's question just now, the rocket now. Okay, there's always never one force, there's always two forces. Okay, in the air, there's always an upward force, and then the air resistance is always the opposite force. On a surface, on a permukaan, there is always a frictional force, unless the question specifically says that it is a smooth surface. Okay, so just now we saw the words rough. Rough surface means got friction. Smooth surface, smooth surface like I don't know whose face is smooth. Kalau kau punya kulit sangat cantik kan dan very smooth, ya lah, Shim lah, maybe. Jennifer is really like, oh, okay, look at my skin is very smooth. Okay, not like my face. My face very rough, full of pimples. Okay, so if smooth surface means no friction. Okay, rough surface means got friction. Okay, so let's remember this lah.